We've looked at ways to be able to find volume using discs and washers. Another way to be able to find the volume of a revolution, which sometimes works better on some problems but not on all problems, is the shell method. The shell basically uses cylindrical shells, meaning a cylinder, and we're looking at the volume of this, which is essentially going to be your circumference, which is 2 pi r, times the thickness, which typically we deal with thickness being like delta x or like dx, times your height. So we're going to use that approach to be able to find the volume of different revolutions. Now your shell method, if you're dealing with a horizontal axis of revolution, is 2 pi r. 2 pi, your r is your p of h. So your radius is always y minus your axis of revolution, or your axis of revolution minus y when you're dealing with this. And then your height of your cylinder is how far you go left and right, which is always what's on the right minus what's on the left. Sometimes one of those numbers is going to be 0 if you're dealing with your axes. Now if it's a vertical axis of revolution, it's 2 pi r, where r, the p of x, is your x minus your axis of revolution, or vice versa, whichever one ends up being positive. Then your height would be what's on top minus what's on the bottom for the height of your rectangle. These are your two formulas that you're going to be using for your shell method. So here we have our x minus x cubed. That's graphed over here, and it's being bound by our x-axis, and we're rotating it about the y-axis. So we're going to take this shape, rotate it around the y-axis, and we're going to use shells to be able to work this out. Since it's a vertical axis of revolution, we're dealing with x's. So how far left and right we go, we're starting here at 0, going over here to 1. So those are going to be our bounds, 0 to 1. Your radius is how far you go left and right. It's how far you are from your axis of revolution. Since we're functions over here on the right, it's going to be our x minus our axis of revolution. So it's x minus 0, because this is 0 here for your x. X minus 0, so your axis of revolution in this case is just x. Then our height. Our height is going to be the top minus the bottom. The top is our function. The bottom is our axes, which is 0. So we got to go our function minus 0, or just our function. Then we need to go ahead and integrate this. The easiest way to do that would be to distribute through your x. Then we can actually increase our exponents by 1 to do the integration. Then plug in 1 minus what we get when we plug in 0. Plugging in 0 doesn't do anything, and we end up with 4 pi over 15. Now, when you're dealing with the disc and washer method, your rectangles that you're dealing with for your discs and washer method are always perpendicular to your axis of revolution. Here's your rectangle, here's your axis of revolution. Or here's your rectangle, and here's your axis of revolution. And that's for discs and washers. However, when you're dealing with the shell method, your rectangle is always perpendicular to your axis of revolution. Or here, they're both going horizontal.